This is Geometry A, Unit 4, Lesson 5. Lines and Triangles is the title. A better title, I think, would be the triangle angle sum theorem, because that's really what it's about. This is one of the most famous theorems in mathematics, and it has been proven a number of ways. We're going to prove it and use it. Okay? And it says this. It says the sum, that means to add, the sum of the angles, of the interior angles, the sum of the interior angles of a triangle, and I should say the sum of the measure of, the interior angles of a triangle, the sum is 180 degrees. Okay? And we use this all the time. It's used quite frequently, and it's been commonly known. But we're going to prove it. So here's the theorem. Let's draw a triangle. Draw a triangle. All right? Any old triangle will do, because it's true for all triangles. If we prove it for one, we prove it for all. Okay, so we have triangle ABC. Okay, with angles 1, 2, and 3. And we're going to prove, so we're given triangle ABC, prove the angles add to 180. So prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Let's set up the proof. We have statements on the left. We have rules on the right. Okay, let's do it. Where do we start? We start with the given, right? Always start with the given. If you're not sure where to start, start with the given. Triangle ABC. How do we know we have triangle ABC? It's given. Now, sometimes in the textbook or in the quizzes and tests, they'll leave this stuff off. I like to include it. Always start with the given. It's good form. And end with what you're trying to prove. Just like entering your GPS destination on your GPS on Google Maps. You want to know where you're going. Measure angle 1 plus measure angle 2 plus measure angle 3 equals 180. We know we've arrived when we end at that step. Okay? Nothing else. At that step, we know we've completed the proof. All right. And I can see I've got a little bit of an overlap problem here, so let's resolve that. Love being able to use computer technology. Just move things around. Can't do that on paper so easily. All right, so let's do it. So we have all these angles. Here's the step that I'm going to do here. I'm going to draw an auxiliary line. I'm going to draw a line through B that is parallel to AC. Okay? Now, it's not necessarily obvious, but this actually relies on an assumption. Okay? This relies on an assumption. It assumes that such a line exists, and it assumes that there is only one line that does that. Okay? So a line through B such that it is parallel to AC. We'll call this line L. Line L. Okay? And so step 2 is draw line L parallel to AC, line AC. And what rule says I can do that? Reason, we need to state the rule. It's called the parallel postulate. Parallel postulate. It is one of Euclid's, it's actually his 6th postulate. And whole fields of mathematics and geometry have been developed based on whether or not this postulate is true. Okay? Through a point not on a line, not on a line, there exists exactly one. So first of all, it exists, and there's only one line parallel to the line. I know it seems like a trivial point, but that's actually a major rule here. So draw line L parallel to AC. So that's called an auxiliary line. Auxiliary line. It's a line not given in the proof, but it is a line that is useful for conducting the proof. And I'm going to label some angles here. I'm going to label angle. Actually, I'm not going to label that angle 4 and angle 5. Actually, yeah, I'm going to label that 4 and that 5. Okay. All right. So parallel postulate is the rule that we're going to cite that gives us permission to draw such a line. Okay, so step 3. We now have L parallel to AC. So I can now say angle 1 is congruent to angle 4. Angle 1 and angle 4. Think about it for a moment and think of why. What rule says so? What rule says angle 4 is congruent to angle 1? You may recognize alternate interior angles, right? Alternate interior angles. When two lines are crossed by a transversal, alternate interior angles are congruent. Okay? So that's the alternate interior angle theorem. I'm going to shorten that to the AI angle theorem. Alternate interior angle theorem. And for the same reason, angle 3 is congruent to angle 5. Also for the same reason, 3 and 5. Picture it like this. Alternate interior angles are congruent. So 3 is the same as 5. Okay. Now 4. Okay, line 4. What is the measure of this angle right here? Angles 4, 2, and 5. Well, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is 180 degrees. Okay, how do we know that? By angle addition. That small angles add to a larger angle. And the measure of a straight angle. A straight angle measures 180. If I wanted to be totally purist, I'd separate this into two steps. Okay, the measure of a straight angle is 180, and by angle addition, it should add to 180. Okay, so now I think we're ready for it. Step 5. We said, and actually I should be a little more precise here. So I'm going to add another step. 5. If angle 1 is congruent to angle 4, then the measure of angle 1 equals the measure of angle 4. And if angle 3 is congruent to angle 5, the measure of angle 3 is equal to the measure of angle 5. How do we know? That's what congruent angles mean. Definition, congruent angles. Congruent angles are angles that have the same measure. Now we're ready to substitute. Look at this. 1's the same as 4. So exchange 4 for 1. 3 is the same as 5. So exchange 5 for 3. So the next line looks like this. Step 6. Measure angle 4. Going to trade it for measure angle 1. Measure angle 1 plus measure angle 2 is not going to change, plus trade measure angle 5 for measure angle 3. Measure angle 3 equals 180. And there it is. That's what we were trying to prove. Okay? So 6, that's called substitution. All right, so we have just proven that the angles of a triangle make 180. One of the biggest conclusions of all of mathematics, of all of geometry at least. Let me show you how it's used real quick. Okay, this is how it's used. So if you have a triangle, and you know two of the angles, like this is 42 degrees and this is 61 degrees, and we want to find the third angle, write and solve an equation. X plus 42 plus 61 equals 180, and solve. X plus 103 equals 180. Subtract 103 from both sides, and x is 77 degrees. So the angles of a triangle, the interior angles of a triangle, always add to 180. All right.